All right, welcome everyone. We have a fun meeting set up for today. I'm going to do a little bit of a tech update, and I wanted to, use that an FAA regulatory update, and use that as an opportunity to talk about the FAA's Mosaic notice of proposed rulemaking, which has some fantastic gems within its 350 pages. And then we'll do a tech update. We've got Gordon Bease from FT Technologies is going to talk to us about a really cool what will be a vast improvement to pitot tubes. So a wind speed, 360-degree wind speed, directional intelligence for light aircraft. So that's going to be a neat update. But I will start with the FAA regulatory update, and I'm going to try and share my screen here. And let's see if I can get my deck. Can you see a helpful slide yet? Anyone?
We see it.
Okay, wonderful.
Yes.
All right, so I just want to do a real quick sort of overview of the FAA regulations that pertain to what we do in our, in our working group that focuses on recreational and private use aircraft.
Or you can't hear them, can you?
And I think, why don't we all mute just so that we can hear all of my fascinating words without any gaps. So in the US, and obviously different in every nation, we've got some very useful and very open and available regulations that are available to us through ultralight regulations and the LSA certification for aircraft and the sport pilot license as well. And this gives us low barriers to entries for some of these US operators. We have low or no age minimums, low or no training minimum requirements, and no medical examination required. For example, in the ultralight space in the US, we have the FAA's Part 103 regulations. There's no medical requirements at all, or age restrictions, or pilot license required. So it really opens things up to everybody. And with the sport pilot's license, kids can get started training as young as they want to, and they can get that license as young as 17 years. No medical exam is required. If we want to just show a driver's license, we can do that instead of the medical. And we can get this certification, this license, in as little as 20 hours. So it's very. In terms of the aircraft themselves, ultralight vehicles just need to have one person on board, one occupant. The flights can be used, just for fun. It's not for business. Aircraft is speed limited to 55 knots, under 254 pounds, with some exclusions for float and safety devices, and so forth. In the light sport category, the regulations say that we can have up to 2 seats. We can have a takeoff weight of up to about 1,300 pounds. Only one engine though, and it must be a reciprocating engine. So you've got to have a piston engine on board, and there can only be one. And this category cannot include a powered lift or helicopter type aircraft. And we've got some speed limitations to up to 120 knots. Now, what's interesting is that the FAA has just proposed through its Mosaic program to very positive change, have limit be reciprocal. It opens it up to electric or other power propulsion, and we're not limited to type. That opens us up to multiple for this certification category, which is great. All classes are included. It could be a helicopter or powered lift aircraft. The seating stays too, although standard fixed wing aircraft can have up to 4 seats. We've got a maximum speed that gets doubled, and they're proposing completely doing away with the weight that's fantastic and opens up things that just to be aware of. Not a big deal. For powered lift aircraft in this category, a sport pilot's license wouldn't quite be enough, but that just means a little more training and next licensing class, like a private pilot, should be able to fly those aircraft. So these categories of aircraft certification and operator requirements give us a lot of latitude, but the FAA's gone on record to say, look, we're giving you as an industry a lot of freedom, but with that, you've got a lot of responsibility to monitor yourselves through your community. The actions of the ultralight community will affect the direction government takes in future regulations. Well, the ultralight community, that's us. And so what they're saying is, look, do what we're doing in this working group and other groups like it to talk about what needs to be done to make sure that operations are safe, stay safe, and that you guys are staying on the rails to make sure that you're doing the right things to ensure safety. Even though the FAA isn't imposing its regulations on us, we need to self-regulate through our own community and organizations like this. And so I think that's fantastic. I think it does give us a lot of responsibility, but this particular working group and the white paper that we're working on can be a great venue to fit what the FAA is asking and tasking us with doing, which is circling up and talking about what needs to be done to maintain safety. We're not writing regulations, but we're writing recommendations, and we want to have everyone's input. OEMs, seasoned pilots, people with experience, people with that are heavy on tech, the whole gang to collaborate and talk about what we're recommending here. So with that, I just wanted to open it up to any thoughts or questions about how we should be thinking about these regulations. But any thoughts or opinions about Mosaic or these updates?
I have a question for ultralight. If you are too fast, everything else is good, but you are going over 55 knots. What can be done?
So the good news is that limitation is only for indicated airspeed. So if you have a 100-knot tailwind, that's not your fault. It's just indicated airspeed. So it's and that can be controlled by how much power the aircraft is putting out. So we're gonna have overspeed situations with respect to ground speed, but that isn't our fault necessarily.
Thanks.
Does that answer the question?
Yeah, but if you still can't maintain airspeed below that, you need to modify the aircraft to be legal, right?
Yes, exactly. You would need to build the aircraft and its lift capabilities around monitoring, keeping those airspeeds low. And the FAA's position is it's okay if you put a limiter. It can be an electronic limitation. So in the case of eVTOLs, for example, that's just an electronic limitation to say we're gonna be monitoring what the airspeed is, and then putting a cap on the amount of forward power that's there. That's fine.
Thank you.
Yep. What other thoughts, questions, ideas are there about these regulations and these proposed updates? Are they good? Are they bad? Helpful? Can anybody use these? Angelo likes them. I agree, Angelo. I am pro updates, particularly the Michael approves as well, particularly the doing away with the reciprocating engine requirement. That was a bit of my understanding is it was a bit of a mistake the way that it was written. What the FAA was trying to express is that we didn't have turbine engines. Time regs were written 20 years ago, it was kind of reciprocating a turbine. That was sort of it. And they were just trying to say, look, we don't want jet engines on these aircraft. But then as electric and other options developed, it ended up inadvertently excluding them. So the FAA is going back and saying, okay, yeah, we need to make some updates given the fact that the regulations are a few decades old, which is great.
I have a quick question, if I may. How hard is it to make the license for the light sport aircraft?
What was it? How difficult is it?
Hard? What are requirements for the driving pilot license for light?
Right. It's pretty straightforward. The minimum, and it's always, everybody always needs a little bit more than the minimum, but we only need 15 hours of instruction, which is not very much, and then the total requirement is 20 hours, but the other 5 can just be solo time. Now that would need to be in a light sport. We can't do that in a 747. It would need to be in a light sport certified aircraft. Something simple, 2 seats, and a lighter aircraft, which we want anyway. But it's fairly straightforward.
But then there is experimental, right? Which doesn't need FAA approval.
Yeah, so that, but I don't know that we would be able to, if we were working on our sport pilot's license, I don't think we'd be able to fly in an experimental aircraft. I think it would need to be a light sport.
So I will educate myself a little bit more about that. Thank you.
Yeah. Hey, Andy.
Yeah. Yes.
I used to import and distribute light sports. And so you can, a sport pilot or training to become a sport pilot can fly in an experimental, but it must be an experimental light sport. So
got it.
The aircraft still has to be light sport capable, qualified. And there are additional restrictions on the pilot certificate. So things like visual reference to ground, no flight at night. Even if the aircraft expands to 4 seats, the light sport pilot certificate is still limited to 1 passenger. So there are some differences for the pilot certificate because there's lower training, they restrict you to other things. You're not allowed to go into Class A airspace. Typically, you're not allowed to go into B airspace. You can get an endorsement, but typically, it's designed for people that are going to fly in more remote areas where less training is required. And I think Andy froze.
Whoops, I lost you there for a second. But thank you for that clarification, Michael.
My pleasure.
Can you see me? Yeah,
Yep.
Perfect. That's great.
Let me unmute myself now.
John.
Yeah, I hear you, and I'm thankful for the answer.
Excellent. We've got a very cool technology update coming in a second, but I just wanted to ask any other questions or thoughts about these proposed Mosaic updates.
When is it likely this to be enrolled to come into effect?
Yeah, that's a great question, and my understanding is that there'll be a few months of deliberation about this. Really, they're opening it up to comments so that we in the industry, if we have feelings one way or another, that we can provide that feedback to the FAA. But it could take, it could potentially take another year before these are regulations that we can actually use in the field. The good news is there's multiple OEMs that are working on aircraft designs that really didn't didn't have a good place to fit before. I'm thinking of, like I think Air One in Israel, or Durrani aircraft in South Florida. They've been working hard for a couple of years to manufacture electric multicopters that didn't have an easy place to fit in the regulatory world, and now this gives them a nice place a nice niche to live within. So, and I think that's what they were hoping. So that's all good news for them. And it, because they're in development, a year timeline is not necessarily a problem for them. And I'm sure there's many other operators and aircraft manufacturers that already are building aircraft that could be kit aircraft, or import, like what Michael was talking about doing, where they say, okay, great, there's a place for my aircraft now. One that comes to mind is the Alpha Electro, which is a pitot aircraft, certified by EASA, and really, really low DOCs. It's a super exciting trainer aircraft that can fly for about an hour. It's ideal for student pilots because of the low DOCs and ease of flight. But because of these regs, it hasn't had a place to live in the United States yet. The aircraft already exists. They've been manufacturing it for a while. Now that we're potentially doing away with the reciprocating engine requirement and allowing electric motors, then great, they can slide right into that position, in a year or so when these regulations get approved, and we'll have a really nice electric trainer that, frankly, students are going to love because the operating costs are very low. Neighbors are going to love even more. You can't hear the thing, especially when it's got any kind of, it's just, it's a little whoosh, because there's no reciprocating engine. So it's going to make a big difference to the industry, and people can start working on the plan now, so that they're meeting up with, they've got their aircraft ready and their import ready and everything, hopefully when the regulations are ready.
I suppose all these manufacturers that didn't fit into this category could still sell locally and use these aircrafts in local states, right? Areas.
Yeah, for sure. Michael, was that something that you were working on in the past?
I'm not completely understanding the question. What do you mean by, can they continue to sell locally?
No, I guess they right now can sell locally, not within regulations for USA, and they can fly legally there, right? Like,
do you mean in Europe?
Whatever area they're in.
Yes, outside Europe. So the example of the pipistrel is a great example.
Yeah. Yes, I'm from there.
Yeah, as long as it meets the regulations of that country, you're fine. And as Andy said, the problem in the US was the light sport regulation did not allow for electric motors. And so this will allow for electric motors, and then opens up not only future aircraft that have electric motors or hydrogen fuel cells or whatever new technology comes along, since it's not specific to reciprocating, it also changes some aircraft that now can be flown by a sport pilot. So a sport pilot can only fly a light sport aircraft, and the number of aircraft that fit into the light sport aircraft category was very small. And so as pilots age, they don't want to get a medical exam, because if you are denied a medical, it's very hard to ever get your pilot certificate back. Instead, you can let your medical certificate lapse and use your driver's license, and you effectively downgrade from a private pilot to a sport pilot by letting your medical certificate lapse. And so this then keeps pilots flying who may not be able to pass a medical exam.
Thank you for the answer.
Yeah.
That's great. Any other questions or comments about the regulations before we move on to our technical briefing? All right, well then I'll ask everybody to mute if you haven't already. And I wanted to introduce Gordon Bease, who's with us from the UK today. Gordon manages North American business for FT Technologies. FT Technologies manufactures a highly accurate wind sensor using ultrasonic technology. Why is this interesting to us? This is an application that was originally developed for windmills, for enormous electric windmills. But this tech can also potentially replace pitot tubes, which, as pilots are familiar, pitot tubes measure ram air pressure coming from one direction. And this type of sensor that FT is working on actually measures airspeed highly accurately from 360 degrees. That could have some great applications for us as we're, the aviation world is moving from aircraft that move, that direction and that direction only to aircraft that have are moving in all directions and can benefit from intelligence or situations that get out of bounds that make things dangerous. A big positive amount of step for us with respect. So, electronics engineer with a master's degree in sustainable. He's been focused on growing business at FT Technologies for years now. Where's yours?
Yeah, hi. Sorry, Andy, your audio was cracking up a little bit there. I hope that y'all can hear me quite clearly. Been having some technical issues with loading the presentation, and there's a key couple of pieces of video in that presentation that I want to show. So I've been, while you've been talking, I've been rebooting my laptop trying to make it work. So let's keep our fingers crossed that this is going to work out. So yeah, I'm Gordon Bease. I work for a company called FT Technologies. The company is headquartered in London, where I am currently this week. I'm heading back to the States tomorrow. I live in Texas. And Andy and myself first met at the Vertical Flight Society meeting in May. And Andy saw our products and he instantly got it. There was no real need for me to explain why we were there. So I'm going to run you through about what our product is, a little bit about the company, but really about how we foresee how our product can fit into the VTOL community. I will say that we are working with some of the major manufacturers. When I say working with, we have supplied them product. In a lot of cases, in all cases, in fact, they've made us sign non-disclosure agreements. And despite that, they are still not really telling us what they're doing with our products. So I'm not going to be able to talk in any specific detail or show you any examples, but I will have some case studies to show you using our sensor. And you guys are all smart people, and you'll be able to extrapolate what that video shows to how it would maybe provide the information that we hope it would be beneficial in the VTOL community. So I'm going to go and share my screen and cross my fingers that this is going to work. Hopefully you will be seeing a presentation popping up in front of you, which is called Low Airspeed Measurement for AAMs. If somebody can give a thumbs up that you can see that, that would be great.
Looks great.
All right, perfect. So what you're looking at is our wind sensor mounted on a small drone platform. We are flying these on smaller drones, but our technology and the size of our sensors, I believe, lends us to the AAM community also, as well as the smaller drones. This is the takeaway that I want you to have. If you don't remember anything else about what I say today, this is the message that I want you to take home, is the FT manufactures the world's toughest wind sensors. And I know that's quite a claim. And we've had people come up to us at all exhibitions and challenge us, and we can actually defend this. So I'm going to tell you a little bit about that. We're headquartered in Sunbury in the UK. We've been making wind sensors for over 20 years. Currently, it's our only product. We don't make data loggers. We don't make any other kind of meteorological sensors. We just make wind sensors. And our largest market for our products is in the wind energy market. So if you look at these wind turbines installed all across the world, on the backs of the wind turbines, called the nacelle, are typically, that's where you put your wind sensors. And the wind sensors forms part of the control system for the wind turbine. So it's got a really important job. It tells the controller the information that it needs to make key decisions, such as when the wind is blowing too hard, it needs to curtail. Which direction is the wind blowing from? And then you need to yaw that direction to harvest the maximum amount of energy from the wind. Information like that is required on a wind turbine. If you don't have any wind information, you have to curtail, and then you're not making any money. So it's a really high demanding application for our wind sensors. And the thing that sells our technology into that market is reliability. So you need to have a sensor that can give over 99.9% data availabilities in all weather, in all environments. And also long lifetime. So typically we're 8 to 10 years lifetime on top of a wind turbine in all kinds of horrendous weather and lightning and hail and all that kinds of stuff. So our product is based on our proprietary technology that I'm going to go into a little bit of detail about. But at the facility in London, we've got full scalable production facility. We do test, repair, calibration in our wind tunnels that we have here. We've got state-of-the-art wind tunnels. All of our research and development is done here. And then around the world, we've got offices in China, Denmark, Spain, and I'm the guy in North America. So what makes us different? You've probably seen ultrasonic wind sensors someplace. They all work off a technology called time of flight, which basically uses the Doppler effect to measure the transit time of an acoustic pulse from one transducer to another. That's great technology, but it can be prone to vibration. Under very heavy vibration, those path lengths can change and they can pollute the measurements, and they can affect the accuracy of the sensor. Now, what our sensor uses is a technology called acoustic resonance. It's unique and exclusive to us. We're the company that patented it. And what it does is it gives you a standing wave, in an acoustically resonating standing wave in the cavity. And we measure phase change. As the wind blows through the cavity, it causes a pattern to change, and from that there's a phase change. And from the phase change, we get the wind speed and the wind direction. So that means that we are immune to vibration. It also means that the measurement of the wind is independent of air pressure, air temperature, and humidity. There's no moving parts. There's no periodic recalibration or maintenance that's required. And our sensors are designed to give a cosine response to inclined flow. So that means they're perfectly predictable and repeatable. And every sensor is traceable by serial number and individually calibrated in our wind tunnels. So you know that you're getting a sensor that's traceable. If it ever comes back to us, one of the first things that we do is put it in our wind tunnel, and we never find any drift. So there's no electronic drift. There's no mechanical drift because there's no moving parts. So we get an acoustic resonance wind sensor, which is in a very small form factor compared to a lot of the time of flight sensors. So I'm going to try to play this video now embedded from this presentation. And if that's not going to work, I will move out to a browser that hopefully that will play from. Okay, so give me a second. That's not going to play. So I'm going to stop sharing. And I'm going to go to hopefully the browser and then reshare, and we'll get it playing from there. And this video should have audio that plays, and it will be a better explanation than I can do myself. And it's about 2 minutes long, so hopefully this plays and you all can see it properly. I don't have audio playing on my end, so I'll presume that you can't hear anything, and I'll walk you through. So this is a depiction on a wind turbine. It's just our biggest market, just for illustration. The wind speed and direction and temperature is measured by the sensor. You can see the measurement cavity highlighted in blue. So this is a 2D sensor, not a 3D sensor, but it has a cosine response, as I mentioned. The transducers live in the top part of the sensor and they provide the acoustically resonating wave into the cavity. This gives us an extremely high signal to noise ratio. It's a very strong signal in a small space. And as the wind blows through, it distorts the pattern of resonance. And from the distortion, there's a phase change. And from the phase change, we can calculate the wind speed, wind direction, and from the frequency of vibration, we can calculate the temperature. Future variation of this product is also going to have pressure in it, atmospheric pressure. We believe that this is going to be released by the end of this year, so it should be available in product from next year. The products are heated as well, anodized aluminum bodies. It's a great conductor of heat. We found that in the wind turbine industry, for example, there's lots of very fast moving cold fronts that can come through a wind park, and it can deposit a lot of ice very quickly. So we have actually certifications which are from MIL standard 810G for anti-icing and de-icing to enable those sensors to perform ice-free through the harshest storms. And you can actually heat the sensor of the body of the sensor up to 55 degrees centigrade. Even at 55 degrees centigrade, these things are only taking 99 watts. So they are quite miserly on the amount of current that they draw for the heaters, primarily because it's a very compact shape and the body material is anodized aluminum, which is a great conductor of heat. And here you can see a few illustrations of where our sensors get used. And there the video should be ending pretty soon. Now I'm going to jump back into the actual presentation. Second. Sorry for all this jumping around. We didn't realize that the video wasn't going to play, and it actually played in my earlier run through. So let me skip ahead. So you should be able to see a slide now that says FT wind sensors key attributes. Excellent. All right. So the key attributes, you can see our wind sensor compared to a person's hand. They're very small, they're very compact. There's no parts that stick out all over the place. They're relatively small. They're very lightweight. This is about 252 grams for this particular model called the SM. Low power, so they take about 31 milliamps, and you power them from a power supply from 6 volts DC up to 30 volts DC. They are size, weight, and power optimized for drone use. These are industrial quality sensors and not research grade. They're proper industrial quality. From the technology that we developed over 20 years ago, which was originally developed for battlefield applications and then found its use in wind turbines. Physically, they're extremely tough. They're the world's toughest wind sensors. The calibration is traceable and they're immune to vibration. And although our sensors aren't pitot tubes, they can perform that function. And we have customers who have actually replaced pitot tubes with our sensors on fixed wing drones. But they do that with more precision and functionality. As Andrew had mentioned, a pitot tube is really great in one direction. As soon as you start blowing from the side, it's not so great. Also, one of the other issues with pitot tubes is that they tend to be inaccurate at lower airspeeds because it's a pressure relationship. We don't work off of pressure, we work off acoustic resonance. So we have a totally linear and very accurate low airspeed measurement. So mounted on a VTOL AAM, they can measure 360 degrees at airspeeds from 0 to 145 knots. So we've got a very wide range there too. Why are we the world's toughest wind sensor? Partially because we pass over 30 independent external tests. A lot of these are related to weather, but a lot of them are related to operations and what might happen in the real world, such as someone dropping them. You know, they go in all kinds of high vibration environments. We've got gas discharge tubes built onto all the boards inside our sensors to make them very, very resistant to lightning. We've also worked with specialists in the field to determine that lightning immunity. We douse these things in rain. We put these on offshore wind turbines, so they're constantly drenched in salt water, getting exposed to corrosive salt water, but there's no corrosion. It's an anodized aluminum body, which is very resistant to corrosion. We've done wind tunnel tests on these up to simulated 4,000 meters altitude, but in fact, our technology will go much higher than that. That was just the limitation of the tunnel. We do all kinds of shock tests, drop tests, etc. So hopefully you're getting the message that these are more tested than any of the other wind sensors on the market, and that's why we can really make the claim that these are the world's toughest wind sensors. In terms of the resistance to EMC and RF, we've got 9 individual certifications related to that. You can put these on a drone, which is effectively a portable receiver transmitter, and our sensors also don't emit, so they are not going to interfere with any of the sensitive electronics on a drone either. And then this is the next video that I would like to show. I'm going to have to go into another application in order to do that. And I wanted to illustrate with this video that you can measure the wind. Just a second, sorry, I'm trying to talk and do this at the same time. Let me share my screen first, and then I'll start talking again. Okay, can you see this? This is a video with, there should be 4 panels on the screen. The top right should be a series of graphs. Excellent. Okay, I'd like to draw your attention to the graphs up on the top right. The bottom left-hand side graph is going to be the real-time wind speed and direction from our sensor, which is mounted on that drone. So the pink line is going to be the wind speed. The blue line, dark blue line, is going to be, I'm sorry, that's going to be the wind speed in dark blue, and the pink is going to be direction. If you look at the bottom right-hand side, you see the picture of the drone. That's also going to tell you what the altitude is. In the current frame that's there, it's above ground level 6 meters. And you're going to see it's going to go way up to the hub height of this wind turbine, and it's going to measure the wake behind the blades. I'm going to scroll through it a little bit to get to the interesting parts, but we're sampling here at 10 hertz, 10 measurements per second. And you'll be able to see the pulse of the wake as each of the wind turbine blades goes past the wind sensor, which is pretty cool. Some of the other things to look out for is the wind speed changing, the direction changing as you're doing ascent and descent, and also flying away at constant altitude. So I'm going to let this play just now, and then I'll scroll to some of the good bits. So you can see just now that the drone is starting to ascend. It's up to 11 meters now. It's going to go all the way up to, I believe, about 120 meters in the air, which is just above hub height for this particular large turbine. And I'm just going to scroll forward a little bit so that we get up closer to the wind turbine blades. And we're going to go in here. So now we're right above the helicopter landing deck. You can see on the blue line, you can see a lot of pulsing going on there. This is from the wake that is generated from each of the turbine blades turning. You get a rotating vortex. Actually, putting wind sensors on the back of a wind turbine is one of the most horrible places you can put them to measure the wind, but unfortunately that's convention nowadays. So we provide a very reliable wind sensor in order to do that. And the wind turbine manufacturers actually have a trick up their sleeve. It's a mathematical formula which is devised for their particular wind turbine in that particular location, and it's called a nacelle transfer function. And what that allows them to do is to take the measurements from our sensors, which is in the rotating wake. They apply this mathematical function to it, and that gives them the approximation of the free stream wind before it hits the blades. I'm not sure if there is an analog in the helicopter community for that, but that's something that's very interesting. So you can see we're right now over the deck, we're behind the blades. We're going to tilt up and we're going to see those blades right in front of us. So right now we're only a few meters away from this large rotating object. It's nice to see that the drone isn't getting sucked in and destroyed. This is actually video from the University of Aalborg, and their motivation for doing this is because they wanted to fly an $800,000 drone cargo carrying drone to wind turbines without curtailing them to deliver equipment. And they wanted to measure the wake behind the turbine blades to make sure that their $800,000 drone wasn't going to get damaged by all kinds of turbulent wind. So yeah, you can keep your eye on the blue line and the pink line, and you can see how, you know, dynamically we're recording all of this wind information while we're in different flight modes on this drone. And that's a highly vibrational platform as well. So the other thing I want to leave you with is our technology of acoustic resonance is the only one that's will operate free of vibration. So I'm going to stop sharing that. I'm going to go back to my presentation now. Oops. Just a second. What happened? Just give me a second to go back and resume. Screen. Now, the next slide. So you should see a slide now that says FT wind sensors rolling VTOL AAM. All right. So when I mentioned that when Andy and I first met, I mentioned how he instinctively got what we were trying to do. This is kind of it. If you can find a place to put our wind sensor on a VTOL craft, you can use it for multiple different things. I'm going to talk in general terms about this because the sensors that we have out there with the actual VTOL manufacturers, we're not authorized to talk about them. But for situational awareness, if you're taking off and landing at a vertiport or from the top of a building or a park or something like this, all of the advantages of VTOL is that you don't have an airstrip, you don't need one. But you're probably going to be taking off and landing someplace where you don't have a weather station either. So having our sensor on your VTOL craft is like having a mobile weather station with you. You can monitor the wind all the time. Is it safe to fly? Is it safe to fly right now? Is this a go, no go situation? But then also when you are doing your takeoff, landing and hovering, critical phases where your craft, your highly, your expensive craft might be at risk from crosswinds and being damaged, flipped on its side or whatever in takeoff and landing, you can monitor that. I don't know at this point whether that needs to be part of a control system or whether it can just be advisory, but certainly our sensors can help you to understand what's the ambient conditions right now. And then the other thing we've been talking to people about is the transition from vertical takeoff into horizontal flight and that loss of lift that you're going to get. One purpose of our wind sensors might be to orient into the wind so that you've got less of the loss of lift. And then the measurement of forward flight airspeed. So that would be replacing the use of a pitot tube using our sensor. We actually have a Japanese company who has ditched their pitot tubes and moved over to our sensor on their fixed wing drone, which takes off and lands on water. So it's not a VTOL. It actually takes off on the water and lands on the water conventionally. But their pitot tubes were getting blocked with water and they were becoming completely useless. And although our sensors don't look like they are the most aerodynamic design in the world, they've been perfectly happy with them on the nose cone of this fixed wing drone that they have. And the advantages of not having blockage from the water like the pitot tubes have far outweighed anything else. So they're perfectly happy with that. Showing some pictures now mounted on helicopters. The top right-hand side, this is the actual cargo drone that the university wanted to use to fly to the wind turbine to deliver equipment. So you can see they also put a wind sensor on the bottom of that high-priced drone, mounted upside down under the fuselage where it's somewhat protected from the large wake by the rotors. We also see a smaller UAV on the bottom right-hand side picture. And then on the on the far left here, this is actually a picture that I found public domain. It's an Airbus H160, as you can obviously tell. So I'm obviously not allowed to talk to about anything that's protected by an NDA, but this is a public domain picture from the internet. And you can see that this particular design of helicopter has a fenestron, and they've mounted our sensor on the tail of that fenestron. Just an interesting use of our sensor. And so coming to the end of my presentation, and I'll take any questions that you guys have for me, but the takeaway here, what do? We make the world's toughest wind sensors, and that's kind of it. So thank you very much for the opportunity to present to you guys today. And sorry if it was a bit disjointed with changing the applications and such.
Gordon, that was absolutely excellent. Thank you so much.
Thank you.
Had Bruce. Bruce had posted a question to the chat, and he had noted that most of what we talked about today was with respect to having one of your wind sensors on the vehicle itself. He asked, "Are you also looking at use for ground-based systems for AAM in regard to weather information systems?" And I think you did touch on that, but could you elaborate?
Yeah, we're actually talking to manufacturers of vertiports right now, manufacturers of drone-in-a-box systems. We work with some of the larger weather companies to push our products out into the market, because we only make the wind sensor, and the wind sensor needs to be integrated with the data logger, for example. We don't make the data logger. So there are some companies out there that carry our products and integrate those for us into weather stations.
Perfect. And speaking of data, the founder of Aero Telematics has a question for us. Danny, I see your hand up.
Hey, thanks. That was a great presentation, Gordon. In fact, I've got a slew of questions. I'll kind of roll them off and pick and choose as you like. One question was on drag associated with the smaller drones that you pictured. Does that have any effect on the
I think your audio broke up at the end there, but I think I got enough of the question, which was, does the shape of our sensor produce any drag that affects the flight dynamics of the drone itself, the small drone? We haven't seen that. One thing that we were on the lookout for was the inverse pendulum effect, which you might get if you have a very heavy sensor on top of a long pole, for example. It seems that the weight of our sensor, which is 252 grams, and by the way, we also are releasing a lightweight version of our sensor, which is going to have a plastic body early next year. That's going to weigh about 140 grams. But we think that the combination of low weight of our sensor and a shortish pole, most people aren't running more than 20 to 30 centimeters length on their pole. It's not enough to give an inverse pendulum effect. We do see a lot of pitching, of course, into the wind when these drones fly. We see pitching up to 30 degrees, something like that. And that's no problem for the cosine response of our sensor either. But in terms of the flight dynamics, it doesn't seem to affect the dynamics at all.
Okay. And on the z-axis relative to your device, are you able to measure velocity in that direction as well?
No, but we've got some case studies on our website where people have used two of our sensors mounted orthogonally to do 3D wind. So one of the advantages, I think, on a multi-copter application for our wind sensor is that it eliminates the non-horizontal flow. So you don't get that pollution. And using a second sensor mounted orthogonally, mounted horizontally, allows you to get that true Z direction flow. The application,
okay, great. And
the case study that I'm thinking about on the website was actually done by Embry-Riddle, and Dr. Adkins from Embry-Riddle had taken our sensors over to Kosovo, and they were studying the flow in urban canyons for their AAM department and course that they teach at Embry-Riddle. So that's why he used the 3D wind sensors there.
Great. And it sounds like rain or fog don't affect that standing wave, or there's no calibration effect.
Absolutely,
okay. And is this principally designed to be integrated into the design of the drone or the aircraft itself and into its systems, or are there also use cases where they're being mounted? And well, it sounds like the use case associated with the wind turbines was one where it's not necessarily a part of the control system. It's basically using the drone to get the device into an environment where now you are able to do remote ambient measurements, in which case maybe emergency services, firefighting,
Yeah.
even package delivery.
Yeah.
While zip both use cases are being. It sounds like both use cases are being explored.
Yeah, absolutely. Yeah, we hope that our sensor is agnostic to the drone platform. We make it with an industry standard output in either RS422 or RS485. You may have heard of the communication protocol called NMEA 0183. That's all standard with our products. So they're typically plug and play. A lot of people are running the SM metal-bodied sensor on M600 and M300 drones, for example. We very rarely get involved in integration issues, whether that's Arduino, Pixhawk, Raspberry Pi, whatever it is that they're using. So it seems that there's an ease of integration there due to the fact that it is an industry standard output. And yeah, we're flying the sensors for all of those applications that you're talking about. Another one that we would maybe add to that would be CBRN, which is typically a military application, chemical, ballistic, radiological, nuclear, detection of flux quantification for those, but also for methane detection, possibly for CO2 as well. So yeah, there's a lot of really good use cases on drones. Yeah, absolutely.
And we just have about 3 minutes left, but Brian, do I see your hand up? And you may be on mute, Brian. While we're waiting for Brian, John, did you have a quick question?
Yeah, I have a question. I think he mentioned speed limit that it can measure, speed limit of the wind. Does direction still get recognized?
Yes, it does. Yeah, all the way up to 75 meters per second. And in fact, we're just about to release what we call a Typhoon class sensor, which measures up to 90 meters per second. It's going to be in a slightly different form factor, though, because it's really for a wind turbine. But that technology could possibly be extended into a smaller product if required for this market.
But what about direction of the wind? Is it still measurable above speeds you mentioned or not?
Above the speeds?
Yes.
I would need to get back to you on that. That's a great question.
Thanks.
Let me take a note for that. Okay.
Brian, it looks like you're still muted, but I've got a quick one. Well, maybe this isn't a quick one, but Gordon, for drones and United States ultralight aircraft, we don't need any kind of certification. You can install today. How about for certified aircraft? When we're talking about potentially installing your equipment on a EASA or FAA certified aircraft, what's next for you in terms of the required certification?
So we have spoken to some potential customers about DO 160 and DO 178. Those are very serious certifications that we would have to think very hard about as a company if we wanted to pursue them. It would require us completely rewriting the software for our products. The easier path for us is to come on as an advisory role at this point, rather than a control system role that would require those certifications, is my understanding. But I'm willing to listen to the views of the experts out there to let us know what they need.
Well, I'd love to see you on at least minimum all the drones and all the Part 103 ultralight eVTOLs possible. That's a great starting point for you, which you can do today. And this seems like a great data set generator and safety mechanism, which I love both of those.
Okay.
And
Hello,
Brian, we have 1 minute left, but Brian, you have the floor. You'll be the last question.
Thank
Hi,
you.
Brian.
Hi, how's it going, Gordon? I have a
Good,
question. I don't know if this is already answered. I mean, you referenced using 2 different sensors to get a better sense of a full space of velocity directions, but are you currently working on a sensor that would have a 3D wind sensing capability?
No, we don't. The architecture of our sensor makes that difficult because we've got the cavity that needs to be, bounded on the top and the bottom itself to provide the reflections of the transmission for the standing wave, I should say. So that's going to be kind of difficult for us to do. What we have done for one of our customers who strongly wanted 3D wind on a ground-based system is that they wanted us to provide the 3D magnetometer data from our sensor. So we're able to provide that, and then through sensor fusion, they're able to link those 2 sensors together in different parts of the truck.
Okay.
Yeah.
All right. Well, thank you very much, Gordon. I appreciate that.
Absolutely. Thank you.
Andrew, you're muted.
Okay. The question now is, will what I say now be better than mute? Probably not. But I wanted to thank you, Gordon, very much for an excellent presentation. I see tremendous safety applications and data output that's going to be super useful. So this is wonderful stuff, and we'll be watching and would love to collaborate with you on anything we could do to get your technology rolled out into certainly the Part 103 space to get started. So that'll be good stuff.
Thank you for the opportunity to talk today. And if anybody has any questions after this, please feel free to contact me.
Outstanding. It's fttechnologies.com, is that right?
Correct, yes. Gordon.bees at fttechnologies.com. And I'll provide you with the presentation, Andrew.
Great. I'll blast it out to the team. All right, everyone, with that, we're at time. I'll let you move on with your day. Thank you so much for being here. And again, thanks, Gordon, for an excellent presentation.
Thank you, everybody.
Thank you.